Hi, my name is Winslow, and today I'll be explaining the fifth assignment of my computer system design class, where I designed a digital watch using interrupt from private timer. And I want it to look like this in the Terraterm using UART. This is my code. I just included some macro for the UART initialization and some header files that I'll be using inside this code. This is the vector table, which will branch me to IRQ ISR whenever an event happens inside the private timer. Okay, this is just setting up some stack pointer for specific modes and the vector-based address register of the vector table right here, and enabling the interrupt inside the CPSR register. Okay, this block of code right here is the setup for the generic interrupt controller, where we can just enable specific IO devices interrupt and manage some priority. Okay, like right here for priority for the private timer, and right here is the private timer setup. Okay, and I decided to use a prescaler of 99, and we want the event to happen every 1 second. So in this formula right here for the time interval, the peripheral clock of the Z board is 333.33 megahertz. So we have a load value of 3,333,299, which I stored right here as hexadecimal timer initial. Okay, we load the private load register, and we store the load value right here, and we want to store the prescaler. We want to enable IRQ, auto reload, and timer inside the control register of private timer. Okay, after doing this, we initialize the UART right here, and this code will run forever, and when the private timer counts down to 0, an event will occur, an interrupt will occur, and it will lead us to this vector table. Okay, if we jump to this breakpoint, we can see that it will branch us to CSD IRQ ISR. Okay, this is the ISR, and the first step is storing all the registers that we need inside the stack. And we want to get the value of interrupt acknowledge from the interrupt acknowledge register, and I stored that on the R3. And for the address of the XRX50 of UART, I stored it in the register R4. And for register R5 to R10, I just stored the address of these the digits of the digital clock, which is initialized right down here. Okay, what happens next is we want to output the digits onto Terraterm using UART. So we just load the value of each digit, we convert it to ASCII by adding 0x30, and we store that onto the TX50 register, and it will show up in the Terraterm. Okay, it's the same as everything else. What's important is this output divider, the ASCII value of colon, ASCII value of space, and if we store that, it will show up in the Terraterm. It's the same thing for the minute and second, so I'll just skip through. Okay, after printing out the last second, the important part is we want to reuse the line. We don't want to go to a new line, so we will store some carriage return, and it will go back to the first line. And the important part of this code is updating the next value. So what I did was, whenever the lower digit reaches its max value, we want to increment the next. Okay, so in second 1, we load the value of R1, and we compare it to its max value, which is 9. If it's equal to 9, we want to reset to 0. If not, we want to increment by 1, and we store that back. And we can see that R1 is 1 right here, and we store that back to the address. And for the 10 digit of second, we only increment if the 1 digit of second reaches its max value, which is 9. So we load the value onto R1. We only increment if R1 is equal to R9, equal to 9. Okay, and we want to compare to its max value again, which is 6. If it's equal to its max value, we reset to 0, and we store that back to the address. Okay, and since at this point the R1 is 1, we don't want to increment the 10 digit of second, so it will stay as R1 will stay as 0. Okay, it's the same concept for the minutes. If we increment 1 digit of minute 1 when we reach the max value of 10 digit of seconds, and same for the 10. And it's a little different for the hour because our digital clock can only go up to 23, and we want to show hours like 19. So we want to check the 10 digit of hour. If it's less than or equal to 1, then the max value of the 1 digit of hour is up to 10. Okay, we want to check that. If it's less than or equal, we want to check the max value, which is 10. If it's equal, we reset to 0, we increment the 10 digit of hour, and we just store the R1 or the 1 digit of hour back to its address. If the 10th digit of hour is equal to 2, we want to compare it to 4 because it can only go up to 23. If it's 4, we want to reset back to 0, increment the hour, 10 digit of hour, and store it back again. Now the 10 digit of hour can only go up to 2, so we compare it to 3. And if it's equal to 3, we reset back to 0 and we store that back again. And after doing the interrupt, we want to clear the interrupt status bit of private register. Okay, then we get the private status register, and since it's a sticky bit, we have to store 1, and if we do that, we clear the interrupt status. And we want to report back that we are done with the interrupt, so we get the end of interrupt register of GICC, and we store back the R3 that we got from the acknowledgement. And we pop back the register that we stored inside the stack, and we return to the next instruction at the point where the interrupt happened. So it's right here, and this will keep going on forever.